Hello and welcome. Thank you for joining me today about this stream on REST Automated Test. I am excited to get started and dig into testing today. Testing is one of my favorite subjects, so we can talk about how that works and see how that works specifically in Rust. I'm going to go over examples of the three main types of tests. So that's going to be unit, integration, and documentation tests. If you are coming from another programming language and you're familiar with how testing works there, these are terms that are probably going to be really, familiar to you, but I am going to just talk about how they are distinct in Rust and in each type of these tests, how they might differ a little bit from another programming language that you might be familiar with. So, yes, I'm just waiting a few more minutes to see if folks are going to join. Good morning, good afternoon, good evening. Please feel free to leave any comments, questions, thoughts, etc. in the chat, and I'll be sure to get to that. So I will point out that today we are going to be going through a Microsoft Learn module. So I don't know if you've had a chance to check out the Take Your First Steps with Rust learning path on Microsoft Learn. This is a newer learning path with a series of 8 modules on Rust. So let me go ahead and share the link to what we're specifically going to be using today. And I'm going to be kind of loosely following along with that, so you can definitely loosely follow along with that too. And come back to refer to it later as well. But I just wanted to show it now so everyone is aware that that's what I'm actually going to be going through for the most part. But yeah, that's about it. So I will point out that Rust does come with a very simple yet powerful test suite built into the language, which is really convenient. If you have used testing, or if you have done testing in another programming language, you've maybe had to incorporate some kind of framework that wasn't just built into the language natively. So it's nice just to have that. You don't have to use any kind of external crate. It's just kind of there for you to use instantly. Testing, really the purpose there is to really figure out how we can write programs that are correct, that are accurate. So it is very important to do testing before you release your project to other folks. You might be familiar with testing practices like TDD, test-driven development, where you might even write tests before you write your code, and it's really important to think about writing tests that you know fail and that are actually doing what they're supposed to do. So those are all just like some best practices and some things that we'll start to cover as we jump into the demo here. I am going to be using Visual Studio Code to write tests, so I would recommend that if you want to follow along, you follow along there. You can also follow along in the Rust Playground. So if you're familiar with that, I can just drop a link into the chat. That is at play.rust/ling.org. So the playground is always a good resource if you just want to go in there and write some code very quickly and run it. So in addition to the test runner that they have there, you could also easily test. Let me just show that out so you can see what I'm talking about. So I have some example here. It does also a really nice job of just keeping the state of whatever you were in last. If you just navigate to this directory, you can have specific links. So if I want to share snippets of code, I can do that, which is also cool. But there is the option to use cargo to run, to build, or to test. So if you want to use the playground, you should use that test option there. But I won't really show that. So if you have questions about it, just let me know. Otherwise, let's go ahead and just jump into the demo. So I am going to start out at my terminal. From here, I'm in this Rust projects directory. For me, that's just convenient so that I can kind of keep all of my Rust projects together in one place. So what I'm going to use here is cargo. And yes, you also need cargo installed, which I should mention that, but if you already have Rust, then you will then also have cargo if you used Rust up, say, to install it. So I am going to create a new library, so --lib, and I'm going to call this math. So I'm going ahead and creating a library. This library create is just going to allow me to have a group of components that can be reused in other projects. So it's going to make it really easy to use this kind of math library and other source files and other projects and so on. And then I want to go ahead and open this up in VS Code. I do already have VS Code opened in the background. So once I'm there, let me go ahead and navigate to open this project. This is a new Visual Studio Code getting started experience. This is exciting. So I'm going to go to open, which you probably can't see that happening in the background, but that's what I'm doing. Going to this new project that I just created under Rust projects, and the library was called math. So I'm going to open that here now. All right, and this is what you should see getting started if you're following along. And hi, Ali, I do see your question. Is Rust a programming language or an automation platform? So Rust is a programming language. And I know I completely kind of glossed over anything about Rust getting started. I guess I'm kind of assuming maybe coming into this that you have a little bit idea about Rust and what it is, but it is a programming language. It has gained a lot of popularity over the past years. You can use it for a variety of things. There's a lot of different use cases, but it is a programming language. I think some people, and we might compare it to like C or C++. I think the big thing and the big draw for Rust is that it is very memory safe. So it allows you to write programs that you just already have a lot more confidence in, because even when you're doing development, about the things that can go wrong. The compiler is really great. The compiler is your friend, and we'll even see that when we're writing our test that it's just super helpful, and you get lots of helpful information as you're writing your code, so you can just feel more confident about it. Is it like Selenium? So no, the answer is no. So no kind of automation there, but I hope that helps a little bit. And definitely go check out the Rust website. We have there's a lot of great resources there, as well as the first link that I shared to the learning path there. The learning path is going to be great. We're specifically going over that automated testing module that you see here. But however, if you go to take your first steps with Rust, or if you search for that, you can even grab that URL from here. You can see that there's all kinds of other modules in this learning path that can kind of help you get started with Rust. So there is kind of the very intro learning module there, understanding common concepts, all the way up until, and we're kind of down far in the learning path. So we're focusing on the right automated test. And then in the next stream that I'm going to do is really kind of going through what's happening in this module. So there is a question about, will I provide commands in GitHub source later? Technically, no. I will provide just another repository that I have where I've done some testing where I think you can get a better idea of what's going on there. But if you do want something to actually have to reference and follow along with later, I would recommend absolutely just going through the Learn module. And let me just show this now since I'm here, because this is kind of where I'm starting from as a basis. But what's really nice about the Microsoft Learn platform is that you can copy code snippets directly like that. So if I go back to VS Code, then what I can do there is just copy this directly in. So I already created this math library, which just kind of by default Cargo provides me this lib.rs source file. And by default, it also kind of gives me this test here. So it is this test, there's no test function actually, or there's no function that we're testing, but this is kind of how a test would look. So I'm just going to get rid of that, and then we'll talk about all this later. But I did just grab this code directly from the Learn module and go ahead and paste it here. So let's just go ahead and start here. Please feel free to keep the questions coming. Thank you, y'all. So now let's just start with some kind of basic math function. Let's say we have an add function. In this function, notice that it is a simple addition. So we're just doing a plus b. We're passing in two parameters here, a and b. One thing that's interesting about Rust is that your functions actually do need to declare a data type here. So I am using this i32 type. So integer types in Rust default to type i32. So I'm just kind of using that there and then specifying that there's going to be a return type, which is also going to be type i32. And then so if we look at these tests here, or this one test, the test basically starts with this annotation here, #test. This is letting Cargo know that this actually is a test function. So if we are just building the project, if we did and I'm just opening up the terminal and waiting for that to load. If I did a cargo build, it should just go ahead and build the project for me. It's not actually doing anything with that test. Notice that to get started with. I can make this a little bit bigger too. What the compiler is telling me is that this function add is never used, but it's saying nothing about the test actually. Let's go ahead. I'm going to hide this for now. I'm also going to hide this because I'm only going to be working in the lib.rs file for a little bit. So if we look into kind of the anatomy of this test, this is an example of a simple unit test here. So a unit test is really kind of just testing out each function. So you can consider this kind of the smallest test that you can do, where typically each function that you write should have at least one supporting unit test where you are really testing the functionality of that particular unit of code. So I can have a variety of tests here. This one is really just saying, okay, add works. I am using this assert equal. This is called a macro. And I know that because it's using this kind of exclamation here. So it's very similar to a function. And when I hover over this in VS Code, I can kind of see information about how to use this macro. I will point out a couple things that are going to be helpful if you are following along in VS Code. If I go over to the left toolbar here and I click on these building blocks, I am using an extension and I wanted to call that out before I get too far. So I'm using the Rust Analyzer extension. I would highly recommend installing this if you have not, and I will point out why in just a moment, but if you want to go to extensions and search for that and make sure you have that in VS Code, I would recommend it. Okay, so why it's helpful for me and what I really like is that you get lots of helpful annotations like this. You hover over code, you get information, there's some nice code completion. I can easily get information about warnings and even possible errors. So for example, this function add, I have this kind of mark here, annotation that something is weird. So if I hover over it, I do see the same message that the compiler told me, is that this function is never used. So I can either, well, that's the view problem. Sometimes it does have a quick fix available of what I can do. I might just need to make this public in this situation so that it's clear that I'm referencing this add function. So I don't know, if it's a warning, you don't have to fix them, but it's good to be aware. It's good to be, smart about this. I think testing, what we're doing now is to build more confidence in our application. So if there are problems, warnings, you might just want to fix them anyway. So I'm using this assert equal macro. In Rust testing, there are just a few different macros that you can use. So there is this assert equal, there is the assert and assert not equal. Let me go ahead and just show where you might get the source for that, or just for these macros, so you can be aware of which ones there are and kind of get a little bit more usage examples about them. So I'm looking up the docs pages, doc.rust-lang.org. So this is coming from the standard library, std, and then this is the macro name. So I'll go ahead and paste that in the chat as well. If you want to go ahead and see that, I can make this page bigger too. So there is the assert equal, which we're using, and this shows kind of sample usage and samples. And then if I scroll down, I think there's probably an easier way to get to that, but you can see the other macros available here. So there's also a regular assert, where we can kind of, let me just click on that. We can assert specific conditions, our results, see some examples of how to use that here. And then the last one that I wanted to point out was the assert not equal. So just the exact opposite as equal. So I'll do my best to kind of use a combination of all of these just so we can see how they work, but just to give you an idea of what's available. And you'll notice I'm kind of jumping around. We're not like getting really into the meat of the test, but I want to make sure that you have all the set of resources available to you as you are writing code. And sometimes as you're writing code, it's not a very linear process either. You do sometimes have to jump around a lot. So I hope that is okay with y'all. So getting back to VS Code, let's talk about this test function a little bit more. So yeah, notice I am using this test hashtag here. With Rust Analyzer, I can run the test this way. Feel free to go ahead and do that. I might recommend going ahead and opening up the terminal and running cargo test directly in your terminal, and we can see what kind of output that we give there. So this does, sorry, we start right here. So this does go ahead and compile the program again. I see that it's running one test. The test is called add works, and that we get the okay result there. So a couple things to call out here. Notice that there are different result blocks for my test. So I have this first one here. So test result okay, meaning one passed. And then I have all this other metadata about my test. There's also doc test, which we'll talk about a little bit later. But basically for doc test, I don't have any. So every time I just do a regular cargo test, it is just going to try to run all the possible tests that there are and tell me extra information, even if there's only one test. You can also do a cargo test -- help, which can be useful. Always would recommend checking out the help pages because there you see different information about how you can use the test command, different options that you can provide. Yeah, and we'll explore some of these a little bit later as well. So with unit test, again, you are kind of just testing each function, the smallest kind of test that you can write to confirm that test work. So right now you'll notice that I am including this test just under the one function that I have with this test annotation. Typically, or more typically, you might want to put test in their own submodule. So a common convention that you see for doing that is to use this configuration tag. So let me go ahead and show you an example of this, and then we can talk through it. All right, so how that would look is above the test code, I can go ahead and add in this annotation. I will need to update my spacing there. So we typically want to use this CFG test tag, so that you see on line 5 there. And basically this annotation is telling Rust to compile and run the test code only when you want to run test. This is just a configuration attribute. That's what that CFG stands for. And just generally, you also want to put test in their own submodule. Just kind of creates a little bit more separation even for your unit test when they're in the same file. And I don't know if I mentioned that explicitly. You do see that example here that this unit test is in the same file as my function, and that is kind of the norm there. With unit tests in particular, they're always going to go in the same file where the function is defined. And I think that's something that I found a little unique coming from other programming languages where you might have test and a separate location, like a test directory, say. And that's where integration tests come in. So we'll talk about that next, but I'm gonna keep going through a couple examples here of this unit test. So we also use this use super here on line 7. So basically this is just saying that code inside of this test submodule, this add function test submodule, is going to be able to access the other code and the other functions in our outer module that we see up here. So that's basically why we're doing that. And then, yeah, that's kind of the test that we have here. So I think I'm not closing this is what's wrong, but then I can close that. So I can go ahead and run the test from here. Again, if I wanted to do that, I can also just run cargo test, but everything should just be fine, because all I did was add my test in a submodule. So there's also kind of more annotations that you could use. So let's say that I start writing a new test and I'm not quite done with it, but how you would want to start a new test again is using this attribute test function add something. You should probably have descriptive names. I don't know what I'm actually going to test here. Of course, you have to consider what you're testing. With this add function, with any function, I want to consider what might be able to go wrong. In the add function, maybe there's not a whole lot, but we can try to write some kind of failing test and see what can happen. What I do want to show is, even if I start writing a test and say, I'm not done with it and I don't, really want to do anything with it yet, or maybe something is wrong with this test, maybe it's like been failing and I can't figure out why, you can go ahead and add an ignore tag. So that's something that you can do if just the test is like not at a place where it's complete for some reason. With this tag, you can also add more information within here. So if I want to say within parentheses, like why I'm ignoring this test, I could say something like not finished yet. Sorry, it's ignore is equal to reason. And, this is why REST Analyzer is helpful. Again, I can't always remember the syntax sometimes, and this is also normal, but yeah, so that's what you might see if you want to ignore a test. Let's also try an example of something else where maybe we try to get a test to fail or do something unexpected. So maybe we should not add floats, let's say. So again, I'm using just regular integers, and this add function, like we kind of see A and B, they're just regular integers, but let's try to add something that we don't think will work. So I can go ahead and say maybe assert equal. So if we call that add function add with, let's say 2.0 and 3.0, that would be equal to 5.0. And let's now just try to run this. I already know it's going to fail, so let's just see what happens in the terminal. But this is the best way I can think about actually trying to get this test to fail. And it's just going to compile and give me an error right away. So that is not going to work. But anyway, I wanted to show an example just if for some reason, and maybe we'll get rid of this now. Instead, if I don't want to ignore, another tag that you can use instead of this is panic. Maybe we'll look into this in our next example that we do. So if you are expecting a panic, and I was just thinking about how to make this function panic, but I'm not sure how to do it. All I'm thinking about is how to get compiler errors. But if your program for some reason is going to fail during execution with something, the program would panic and basically just stop. And so you can catch that in your test by doing #panic and basically expecting the test to panic and just testing, in fact, that the panic does happen. So that is something else that you can do. And we'll look at that example later. So let me just go ahead and run this test one more time, and then we'll move on to look at some more examples. Let me see if there are any questions. Okay. All right, and so we are good here. Just notice, of course, that one is going to pass and one is going to be ignored because I am now ignoring a test. So that's basically kind of the basis of what I want to show with unit tests in particular. I think, the important things to remember here are that they are going to be in the same source file, the library file maybe that you are declaring the function in, and you're just thinking about all the possibilities essentially to test out this function. This is a pretty simple function that we have getting started, so I don't expect a lot of things to go wrong, but just something to keep in mind. So I think next, let's go ahead and jump into some examples of documentation tests. I think would be a next good place to go to. So I think I clicked something I didn't mean to. All right, so documentation tests are unique to Rust because they allow you to actually have living documentation with code examples that are executable as test. So I'm doing something weird here, sorry about that. I think I started the debugger. So even let's say that we want to start writing a documentation test in this file, and documentation tests are also going to belong in the file where the function is declared, since you might be writing some documentation about that test actually. So what they're going to start with is kind of these 3 backticks, triple backticks, that are just going to denote that this is documentation. So generally the first line, might just be a summary describing the function. So you can say like the add function takes 2 integers, and you can add something there. And then in more complex functions, you're going to have a lot more information here about what it is that your function is doing. And then whenever you're ready to start writing your code, what you can do is start with the triple backticks. And then you're going to add in these. So this is going to denote that this is a code block. So this code block is where your documentation, your doc test is actually going to look for this executable code that it can write. So what I would be able to do there, and maybe I'll just take a space and expect a few more lines where I'm going to be able to add in some kind of test there. So for my add test, let's say I want to start with a variable called result. So I can say let result is equal to add, and I want to be able to add 2 integers, so we can say something like add 2 and 3. And then I want to add more of these backslashes here. And I want to point out, I guess, something that I didn't specify with the unit test is that the assertion, you can say, is somewhat optional. So this assertion is not necessary. I think assertions are, well, let me say they're not required. I think they are absolutely necessary for you to actually kind of confirm that your test is doing what you want it to, but already this would technically be a valid test where we're just saying, okay, I have this code that I'm executing and I'm calling this function here, and technically that is okay. But yeah, you probably shouldn't just stop there. So I might want to assert equal that my result is 5, and then stop there. So then I have this test within this documentation that is denoted by these backticks here that are, just indicating that that's code. So now I'm just going to skip a line, and let's say that I want to run this as is. All right. So what I'm going to do is open up the terminal or in with VS Code. And I also just noticed that I was in the terminal. So I think y'all were seeing that for a little while, and I didn't know how long you were seeing that. So it should switch back now. Let me know if there are any problems. Anyway, so if I do a cargo test now, let's see what happens. Oops, okay. And let's go see what is going on. So again, the compiler is your friend. What's really helpful here is that I think I just forgot to do something. I forgot to do a couple things. So, all right, so the first error that you notice here is cannot find add in the scope. So I need to make sure, and I'm actually using the math library before calling that add function. Consider this math add. So let me go ahead and add that. And then I'm also not using this as a macro, which is important to remember that that is the convention there. So how I might want to fix this is to go back to my terminal. And I'm going to go ahead and make this an actual macro. I didn't notice that before. And I'm going to add in that I want to specify the math library that this function is coming from. Even though I'm in the math library, that is just still something that Rust is expecting. So it can just totally be a process of writing your test, and that's okay because you can figure things out in the process. Your compiler will definitely help you to kind of figure out what's going wrong. So what I see here is okay, this test passed, so we're good to go. Next, let's focus on, I want to go ahead and add another function, and I want to start to look at things that can actually go wrong. So I'm going to bring in this example of a division function under this add function. So here I have this division function. It kind of starts out the same, where I'm taking in a 32-bit signed integer type, A and B. I am doing a check here before I do the division. If B is equal to 0, I want to panic. So I'm going to basically stop execution and print out this message, divide by 0 error. If B is not 0, I can go ahead and continue on to do A divided by B. So let's say that I want to add some documentation test around this test. So I can start here with these triple slashes, and I can say the div function will divide two integers. This function panics if the second integer is 0. So I might just want to say something like that. And then next, I can start writing my test. And right off the bat, let's just go ahead and start with a test that we think is going to fail. Because we've already, I think, seen enough examples of happy tests so far. So let's just go ahead and start there. Also notice that I didn't call this out in the first example. We don't have to indicate that this is a test. It's just clear that because we are using these backticks, that this is kind of executable code, and the only executable code that it is expecting is test. So what I want to say within here, after these backticks, is I can use an annotation here. So similar to how we saw the ignore tags, or even how you can put a panic tag with documentation test, you can do something similar. The syntax is a little bit different, but what this looks like is should_panic. And within that, I can put some kind of message. So I'm already going to know that my message is going to be equal to this. So that's what I'm going to expect. And now I just have to think about how to actually implement this test. So it's going to start out similar to how my last test started out, where I want to say let result is equal to math : So it's just specifying that I want to use this function from the math library. And let's go ahead and say divide 4 by 0 and add a semicolon there. And then what I'm going to do is just end this with triple backticks. I guess also notice the one other thing that I'm doing differently here is that you can have spaces or you cannot have spaces. So I can add some spaces in here. And just the only thing that you'll notice is that the highlighting kind of changes. So either way that you want to do it is essentially fine. Or I think that's what was changing, but I just wanted to call that out. Really, the important thing is having these backticks. So let's go ahead and open the terminal again. Okay. And I'm going to do a cargo test. All right. So, all right. So we have, all right. So we'd start here. I sometimes get distracted by the other output. We're running 2 tests. So we're already running our 2 unit test, and then we have our doc test. And it looks like it only ran 1 test, the add test. So maybe I do need to take another look at what I'm doing here. So it is just running that add test. And it didn't run my test. Why didn't you run my test? Yeah, okay, what is happening here? What did I miss? Maybe my syntax is funny. And I also want to show, I don't actually want to run the other tests, so let me just specify how to run the docs test in particular so that we can just focus there. All right, and then to do that, what I want to look at is just to use this -- doc option. So I can say cargo test -- doc, specifically to run the docs test. And yeah, I'm doing something wrong because it's not running this test. Math, div. Let me take this out for a moment. So now you're going to run, right? And maybe it's, oh, okay, and I do have this now, but I do expect this to fail. So then let's see what happens. Running 1 test. Oh. All right, I'm gonna not use that helper and just run the cargo test -- doc again here in my terminal. And now it's running to test. Okay, but we are gonna expect that test to fail. So the add is okay, the div is failing. And I do see here, so this is helpful, and this is what will happen, is that thread main panicked at divide by 0 error. So I see that 1 passed, 1 failed. So that is what I expect, but I do want to be able to use that should panic annotation. So let me go ahead and see what I'm doing wrong there, because there is something that I'm doing wrong. Okay. So let me go ahead and add this back in here. And what we're gonna do, I'm gonna go back to the Learn module and see what I'm doing wrong, or back to the documentation. Either one of those are totally acceptable when you are just trying to figure out like what the problem is. So back at my browser, what I'm gonna do is look into, let's start with the Learn module. So if I go into Unit 4, let's start there where we are just describing how to write documentation test. This can be helpful for you as you're going through documentation test. Rust should panic. So this is what I'm trying to do here. And then there's a to-do to write this documentation test. One other tidbit that I'll call out here is that this is an exercise. So this is a great place to test your knowledge. There is a solution that you can follow if you want to go over to the Rust Playground link. So let's say that you are working through the code there. You can go ahead and just use that if you want. And what I'm looking at is specifically around this example. So they are doing a couple things here. First, what's different than what I was doing is that they're specifying this rest tag or attribute, which is basically just specifying like, hey, this is actually a rest test, which can be helpful. That is something that you can absolutely do. And then should panic. So let me just start with the should panic without any extra code, because maybe my syntax is just off around that. Let's go back to VS Code. So instead of this extra, let me get rid of that for now. And yeah, this even looks better. It's allowing me to run it. I think just notice also the one difference about this test is I didn't have an assertion. So why I would like to use a message here and, you know, not just a general should panic is for me to actually then go ahead and confirm what this panic message is. But let's go ahead and try this. And it already looks like it's going to work. So in my terminal, I can run cargo test again. And now we have the add test that's okay and the division test that's okay. Because we did panic, so it just makes it pass, which is cool. So we're basically just testing the panic, which is what I wanted to show. Before I move on, I do want to call out one more thing, that just in general, the Rust documentation is super helpful. So if you are ever looking for more information about something that you just can't immediately find, you might want to go ahead and check out some extra documentation. So I can go ahead and show a link to that. Let me just open a new tab here. So at doc.rust-ling.org, I might want to go ahead and look for the documentation test example. I can post that in there. But this can kind of give more information. Some of it you might find in the Learn module. I think the thing that I'm specifically running about is using like specific attributes and how to define that should panic message that I want to expect. So there is more information in here in general. So I do see should panic, panic unless attributes. Okay, and here's just an example of more attributes that might even be helpful, like the unit test you can ignore. This annotation is just a little bit different. I can use should panic. I don't see them using a message. Maybe I'm just going to try that one more time. No run. So this no run will compile your code but not run it. That can be helpful for some reason. Okay, cool. But yeah, I do want to point this out. I don't see exactly what I'm looking for as far as adding some kind of expected message after should panic. But I'm going to try that one more time. Maybe the way that I'm doing it was just wrong. And yeah, I obviously can't remember the actual annotation of how this is supposed to work. Because what I was thinking is that it was just expected is equal to, and already when I do that, this annotation just goes away and it like does not make it a rest test anymore. So there's one point where we were also using that rest keyword and that seems to be fine. But as soon as I add that, it does not like it. Okay, yeah, I'm not quite sure about that expected panic message. But that is something that I think would be helpful just to like see how you can run this test with getting the actual panic message. Anyway, so that's kind of the basics of doc testing that I wanted to point out for now. Again, I think that this is super interesting and something that is more unique to Rust because it is going to allow you to write tests specifically for your documentation. Again, we're looking at fairly simplistic examples here, but this can be really helpful, especially for folks that are maybe not familiar with your code. So maybe you're working on a large project, an open source project, someone is coming in and want to get specific usage examples for maybe how to use this particular function. And by reading really detailed documentation about how to use a function and seeing tests, like that can be very, very valuable. I think from experience, I found that to be really helpful. So can be something that you definitely just want to consider. The next thing, and kind of the last set of tests that I want to point out, is going to be for integration test. So let me make this code a little bit smaller. Sorry, I think it's gotten very hard to see. And let me know if there are any questions or there's anything else that you want to try out. I'm going to move on to integration test for now. So until this point, we've stayed directly in our library, our math library. For integration test, they live outside of your library code. And the point of that is for them to be completely separate from your library code. So you're kind of testing them from the outside. So while unit tests are really confirming the functionality of each unit of code and that function, unit tests are kind of looking for more of a higher level and kind of trying to use the function almost as like a black box where you can pass in some input. You don't know exactly what's happening in the function and you get some output. So just a different level of abstraction there. So I want to start with a folder called test, which is going to be at the same level of the source directory, but outside of it. And I'm just going to define a new source file there. So this source file can be called something like integration_test.rb, or sorry, I don't know why. It's definitely not RB. That's .rs. Let me rename that. There we go. We see my little icon there update. I thought this was a Ruby test for a second. So what we want to start by doing with these type of tests is to actually bring the library into this test crate scope. So I'm going to say use math, which is the name of the library. And we're going to get probably a message from the REST analyzer that we're not using this for now. Yes, I know. Let me go ahead and close that out. And then what I want to do, I can just go ahead and start writing test. Test in their own kind of separate integration test file don't need to have any kind of like configuration test attribute or be in their own module. You're already specifying that this is just a file for test. So you really don't have to do any kind of extra steps as you would with unit test here. That's one thing to notice. And let's call this add_integration maybe. And I'm gonna use these curly braces. So then inside of this test, for now, I'm just gonna essentially do the same thing that I was even doing with the regular unit test. So maybe I just have some assertions like this. And I can't now just call that add function directly like I was doing with the unit test. I actually need to specify the library that this add function comes from, and then add that in there. So then an integration test might look something like this. I would say this isn't maybe the, I'm trying to find another word for best, but maybe it's not the best example or like how exactly that you might use integration tests, because here I clearly did just copy what was in the unit test and bring them over here. I think typically, again, from an integration test perspective, you want to kind of approach this with a different mindset. You are actually like testing out that your program works as a whole. So here it's just like the structure of how an integration test would look. Again, I can run the test directly from here, or I'm going to open up my terminal. I always really like to stick in the terminal when possible. And here we can see what is actually different. So the one thing is, yeah, there is sometimes quite a lot of bit of output. So I start with running my unit test, then I am running my integration test here, and then finally my docs test. So for the integration test, I do see that one test passed, which was our test add integration. So we're pretty much good to go there. I do want to point out one more thing. So let's say that my output window, my terminal window is getting a little bit busy. I can say if I want to just run one test, specify the name of the test. So let's just say I want to just run this integration test here. So I went ahead and copied the name down here. So cargo test -- test. Test and, okay, so then it said no test name that. There is a test name that. No test name add integration. I thought that was the right convention. Cargo test integration. All right. Let me clear this and let's go look in the cargo test -- help again. So what I'm specifically looking for -- test is to test only the specified test target. Only the specified example. Okay, let's try one more thing. So cargo test -- test integration _ test. Okay, so the name of, I think that's what I forget. It's that specified test target. So the test target is actually the name of the file, not the name of the test. So just helpful to understand that there are different options for being able to run the specified test. So if you do just want to focus on one particular example, you might want to go ahead and start there. So that's one way to just run this particular test, as well as I can also just run the test from here if I wanted to do that. Kind of gives you the same experience, but it's also just really good to know the commands and be more familiar with those when you're trying to do particular things and just work on one test at a time. So that's kind of the important thing to know about integration tests. They live in their own separate directory. You don't need to put them in a separate module since they already are kind of in the self-contained test target. Their purpose is really just to test whether the parts of your library work together correctly. I did want to show another example. I think with kind of the limited scope of this, basic math that we're doing here, add, division, there's not a whole lot of different scenarios that you can execute for looking at how sophisticated your tests can get, but I do want to show another example. Let me open up my browser. And I think one example that I wanted to point out here, and that could be helpful if you want to go through it, is in this GitHub repository. So this was a repository that I've worked on in the past for this kind of password generator. So this program, let me just go ahead and start with showing you the program. I'll start in main.rs. So the structure of this program is a little bit different. So if you want something to practice on, you can totally come in and look at this if you want. But basically what I'm just building is this very simple command line program that's going to allow me to basically kind of specify a length of a particular password and spit that out back to me. It's just using it's using this generate password function, which we can go look at, but all that's basically doing is generating a random function based on this character set here using the random number generator. I do have some basic checks in here to say, like, if the length is less than 6, throw this panic, else kind of do this random number generation based off this character set. The helpful things to notice here is that I do have some tests. So these are the unit tests that I have to start with. So these unit tests are more useful examples of the test that we just saw, where I'm actually testing that we generate the correct password length. We can generate unique passwords each time. And I'm also testing out the panic functionality as well. So I would call these more useful and even just more depth that we can get in with just an add function. You are really kind of thinking about all the possible scenarios of how you might want to go in and see how this generate password function works, what can go wrong, and just write test scenarios for all of that. You'll also notice that I do have a documentation test example up here where I am basically just showing, hey, here is a very simple way to use the generate password function, and let's kind of go ahead and assert a simple length based on the length that we provided to it. The other thing that I'll point out about this test, or this project, is that there are integration tests. So here, this integration test is very different than what I was just showing, where I'm actually testing that the program execution is successful. So this is a much more typical example of an integration test where you're kind of testing your program from the outside and really you don't have any insight into what's happening in the functions themselves in the code. So I am treating it as kind of a black box, but what I'm doing basically is running this cargo command. So it's almost as if I'm running the program in this test. I am. And then I'm just basically like asserting that the program executes successfully. So this is maybe more of an example of typical integration tests that are going to kind of test your program from the outside. And there's even more kind of examples that we can do in here. We can test, importing various lengths, trying to see what can go wrong you're basically just acting as the user, how you would execute this program from your terminal yourself. So that's kind of what I wanted to show there. I think it's always helpful, just kind of start at some of the more fundamental examples like we were doing in this kind of walkthrough with this Learn module, just to get an idea and really grasp these concepts. But of course, you can always start to get kind of more advanced into other examples. Please continue to walk through the examples in this Learn module. I didn't kind of show all of them. We kind of focused on the basic math, but there are helpful information here, as well as just thinking about how you can kind of go forward and write more helpful tests. So that is what I wanted to show today. I'll go ahead and stop there. See if there are any questions. Thank you all for joining me. All right, so if there are no questions, I will just close here. Thank you all again so much. I would really appreciate it if you could take a quick survey about this event at aka.ms/reactor/survey. The event code for this stream is 12962. And then I also have my contact information there below, my Twitter, my LinkedIn, and my email. So if you do have any questions, please feel free to reach out. I'm always happy to talk more about this stuff. And that is all I have. So I hope that you all learned something new about testing today, and that you all have great days wherever you're joining me from. Take care.